effective solid waste transfer action plan for Rajkot. The image that you see here is not from a dump site but from a waste transfer station in Rajkot. So let's see why is this happening. The issues at transfer station at planning level, technology level and regulatory level are causing inefficiency in RTS, leading to waste skipping the processing and treatment stage and directly going to the disposal. Thus, with an effective waste transfer action plan, waste handling, resource recovery, waste processing, collection efficiency can be improved. This will reduce transportation cost and GHG emission. It will also help Rajkot improve its Swachh Sarvekshan ranking as the criteria for segregation processing and disposal has increased. The aim of the project is to create an effective and efficient municipal waste transfer infrastructure. The objective is to develop a effective municipal waste transfer infrastructure, streamline waste handling, reduce environmental impact, and enhance public health through hygienic waste management practices. National and international case studies were done on the planning, technology, regulatory, and contractual intervention level to provide a holistic view of their effectiveness and potential to replicate. The proposal has three components. First, upgradation of existing RTAs through augmentation of RTAs and updating O&M contract, reorganizing RTAs command area based on future demand, identification of optimal location for future RTAs through a toolkit for site selection and feasibility. For augmentation of existing RTS capacity, according to US EPA guideline, only Rayadar and KS diesel can augment capacity from 200 TPD to 250 and 350 TPD respectively, raising the total capacity from 700 to 900 TPD with a capital investment of 8.4 Cr. Existing circulation of RTS has a long turnaround period. By shifting the weighing bridge from the entrance to the tipping floor will reduce it from 15 minutes to 7 minutes, which will have a better environmental impact, increased operational efficiency, and have economic benefits. To avoid manual handling of waste at RTS, a 100 TPD IoT based sorting and processing MRF and a 5 TPD biomethanation plant is proposed. MRF will require a capital investment of 13.5 Cr and will run on a PPP model. This will reduce the trips to landfill by 10 and thus saving 1 Cr annually on transportation. The capital investment for biomethanation plant is 4.5 Cr. It will also be on a PPP model. This will produce carbon credits worth of 2.4 Cr annually. Further, to identify potential locations for RTS, a toolkit is prepared in which, through GIS analysis, distance from arterial road, residential area, river and streams, and generation centers are considered for site selection. Based on the selection criteria and suitability, a multi-criteria analysis is done and overlapping it with the land use, 6 sites have been identified best suited for new location of RTS. There is the feasibility of these sites, functioning cost, transportation cost, revenue generation from MRF and biogas have been considered. As for a city, functioning cost remains the same for an RTS, thus transportation cost will be the deciding factor for the location. Transportation cost to landfill is calculated for 6 locations and site 6 has the most suitability. Comparing the hauling cost of the waste from the generation center to the respective wards, it is found that even if the cost remains similar, the identified location can serve growing areas. Since the city is growing towards west, thus with the new RTS, there is a need to reorganize RTS command area to better serve these areas. Coming to the last part of the proposal, the bid of the contract will be done in two stages with the winning bid parameters for RTS, MRF and O&M are given here. Scope of work are detailed out in planning, technology and regulatory level. Project is phased in short-term, mid-term and long-term strategies with short-term strategies of upgrading O&M contract, mid-term involves installation of MRF and biomethanation plant and long-term strategies involve optimum site selection and construction, formation of a collaborative contract between MRF and biomethanation plant. This will require a total capital expenditure of 38.5 Cr, which is 77% of the current capital expenditure of solid waste management. Thank you.